All right. So Jacqueline had, in fact, been helping me rehearse an entire introduction, but you already know that my French is bad. And I got to say the most important thing. But anyway, really excited to talk about this. This is a new talk this year. I don't know. We're calling it Innovation, Why the Majority is Always Wrong. If we have not had the opportunity to meet, my name is Michael Carducci. Je suis architecte logiciel. See, it's bad. I'm not even going to try. A software architect, an author, a speaker. I wrote a book. That's my YouTube channel. I like to call myself a holistic software architect for some reason. But then there's this entire other career that I've spent about the last 30 years involved in. That was as a professional magician. Now, I used to think that these were separate careers, that, okay, there's my day job, I go to work, I push buttons on the computer, and then at night I go around to do card tricks and blow minds, but they're not. Right? Magic taught me how to see the world differently, how to question the things that everybody else just sort of accepts. And it changed the way that I think about possibility, and more importantly, about impossibility. So I'm going to show you something impossible. By the way, if these are all wrong, they probably are. Blame AI. That's all I'm going to say. But to kind of kick everything off, I'm going to show you an impossible object. Now, you might be thinking, well, what's so impossible about a card that has a spot printed on it? But you haven't seen the other sides yet, because on the other side, there's 4 spots printed on there. Okay, you're still... Catch up with me, or I'm going to catch up. Like I said, it's been a long day. What makes this object particularly impossible is it actually has more sides than it should, because on this side, there are actually 3. On this side, there are actually 6. And logic falls apart when there's 1 spot here, 4 spots here, 3 spots here, and 6 spots here. But now, if we look at this room right now, and I'm kind of scanning all the faces, typically if you do a magic trick of any kind, the majority is fooled, but the minority is questioning. They're already questioning the assumptions that I, as a magician, am taking advantage of. You see, the brain is a really expensive organ to run. And so most of the time, what it does is it tries to run in like low power mode. It tries to not use the performance cores and use the efficiency cores. And so a lot of the efficiency cores aren't really processing all the input that you're seeing. It's actually kind of filtering it through a mental model that you have, and it's looking for patterns that it's already familiar with, and then it's going to fill in all the gaps. So like, I don't have to do anything to fool you or to deceive you, because your brain's just going to do it on its own. It fills in the patterns without telling you. And so I've already been standing here long enough that you're probably starting to put the pieces together. The pattern that is familiar, the pattern of 6. The hand that is obscuring one of these dots. And now a new pattern is forming. You're beginning to realize, oh, that's what my brain is doing. When this spot is covered, your brain's like, oh yeah, that's definitely 4. And when this side is covered, oh yes, that's definitely 6. And the same thing on this side. When this spot is covered, you're like, oh yeah, that's definitely 1. When this side is covered, you're like, oh, right, okay, that's definitely 3. And so the most dangerous situation you can be in life and problem solving and engineering is thinking that you've already seen the truth, or even that you've finally seen the truth, like right now, because there really are 6 spots on this side. There really are 3 spots on this side. Or at least, I would say, realistically, the majority thinks that the minority of you have figured out that I'm probably not done yet. And in fact, on this side, there are in fact 8 spots. And I do all of this just to make my point that the majority is always wrong. Now, y'all have been very kind to me as an audience. Oh, thank you. Thank you, the half-hearted woo. But you all have been very kind to me. Sometimes magic audiences are a little bit more hostile. There are actually 3 kinds of magic audiences. You do a magic trick, whatever it is, right? You, I don't know, somebody name a card. 4 of, is there 4 hearts in this deck? There is, okay. 4 hearts, right? Whatever that is, we can, I don't know, do something fancy. It's not that impressive, but we could take that, put it in the middle somewhere, and do it again. That becomes slightly more impressive. What I'm actually doing, I'll do it face up so you can see, is I'll leave it face up. It goes in the middle. I do a little move. The move looks like that to bring it to the top. Then I can keep track of it. But the thing is, whatever it is that I'm showing you, like when I show you it's in the middle, obviously I'm doing something sneaky. It's not really there. It's under my control. But the majority just accepts what it's seeing. The minority, they think, they question, they challenge their assumptions. They actually can kind of pause the process and say, oh, I got a bunch of assumptions here. And then there are contrarians. The contrarians are just going to reject everything. Like, if I were to do a magic show for about this number of people, there would be about 3 or 4 people that are just like, he's doing something. It's up his sleeve. Even if they don't know, they've just decided that he's got to try to trick me, so I'm not going to accept anything. So the 3 types, the majority, they just accept. The minority, they question their assumptions, and then there are just the contrarians. They reject everything. And the thing is, this is one of the important things to understand about this topic, is just because the majority might always be wrong, it doesn't mean that disagreement is a shortcut. You can't just disagree with everything. And what we need to do is figure out where that distinction is. What separates the people who have these ideas, who see these solutions? What separates the innovators from everybody else? And the answer is just their toolbox, right? It's all about what's in your toolbox. This is exactly what we were talking about before we started, about why all facets of diversity always manifest in different toolboxes. And the more tools you have available, the more possibilities you open up. And I'll give you an example of how this whole toolbox thing works. There's a television show in the US, I assume it's up here too, I don't know, Fool Us with Penn and Teller. And the whole idea is they're getting the best magicians in the world to show these 2 like career magicians who've been doing this professionally for 50, 60 years at this point. And it's very hard to fool them. It's very hard to fool a magician because magicians usually, especially very seasoned veterans like Penn and Teller, they've amassed a very large set of tools. These are techniques, these are devices, these are sleights, these are psychological subtleties where I can phrase something just right to make it so whatever it is that you say, you think it's your idea, but I planted that seed. Like, that is a real technique that magicians can use. These are psychological subtleties and concepts and things like that. So magicians have this enormous set of toolbox. So you can show most very experienced magicians almost any magic trick, and we can see the answer immediately. It's just that toolbox. And in fact, having that toolbox changes the way that we see the world fundamentally. So what's in the toolbox, though, of an innovator, somebody who is out of step with the majority and sees the solutions first? Well, there was a guy named Everett Rogers, and he wrote the book on how major transformations happen. And he came up with 5 or 6 attributes of an innovator. The first one is they are deeply curious. They are active information seekers. They're the kinds of people who come to events like this on a Thursday night. These are the people who read books. Looking at you, Benoit. Right? They're always consuming, they're always learning. And they enjoy that. They're deeply curious. And as a result, they tend to have a breadth of knowledge. So not just narrow skills in one area, they know different things, little pockets of knowledge across a variety of different topics and subject areas and domains. just, enough to kind of be able to navigate these things. They have diverse interpersonal networks. They know all kinds of people, not just the people who are old white nerds from the 80s. I'm putting myself on that list, by the way. I don't know why I pointed at you. Well, they say every time you point your finger, 3 more point back at you. But diverse interpersonal networks, different people with different perspectives, different backgrounds, different toolboxes. That's a really powerful place to find that innovation. And then we've got comfort with uncertainty, the ability to just kind of sit with an idea. One of the greatest quotes I ever heard, and this keeps resonating every time I think of it, is the sign of an educated mind is one that is able to explore an idea without accepting it. And just be able to kind of sit with that uncertainty, sit with the idea, I might be wrong, I might not fully understand this thing, or I have an instinct that this is the right direction to go, but I'm not 100% sure. But I'm confident enough to try it out. Number 5 is diverse mental models, different ways of analyzing things and systematizing things and processing the various input that we get. And the last one is a willingness to explore new ideas. Just not, this usually comes with this one. If you're deeply curious, you're not only willing to explore new ideas, you like exploring new ideas. Tell me something I don't know. Show me something that I've been wrong about. Like, that's one of my favorite things in the world. Now, as you're watching this, you might be thinking to yourself, I can check a lot of these boxes. And if you do, that means that you represent just 2.5% of the entire industry. That sounds cool, right? Except there's one problem. That guy, Everett Rogers, the guy who figured out that 2.5% number, he figured out something else as well. And when he talked about this, he says that the most innovative member of a social system is very often perceived as deviant from that social system and afforded a status of low credibility by the average members of the system. Now, this man studied innovation his entire life, and he culminated his life's work into a book which catalogs about a century of focused research on this stuff. It's called Diffusion and Innovations. This is the seminal book on innovation, how it spreads. And one of the big ideas in here is the adoption curve. That basically, we have the innovators, the 2.5%. I even put the commas in there for you, trying to do things the right French way. And the ideas tend to spread to a small group of early adopters. They're not quite as isolated from the majorities here. They're a little closer to the majority, but they're also they're the bridge between the innovators and the early majority. If the idea succeeds and continues to spread, it moves into the early majority, the late majority, and then the most skeptical of all people, the laggards. They are usually the last ones to adopt or explore the innovation. But the thing is, this curve isn't just a model of how ideas spread. It's actually a model of who's wrong about the change, whatever that is, and when they're wrong. Because at any point in that curve, and most of the points in this curve, the majority by definition hasn't adopted yet, which means at every point in that curve, the majority is looking at that innovator and they're seeing a deviant. So the majority isn't wrong because they're dumb, because they're foolish. They're wrong because they're optimizing for the past. They don't have enough information yet to see what the innovator sees. I'm going to make my copy of this all a little bit bigger. I'm realizing I probably already need a new pair of glasses. The thing is, consensus is a lagging indicator. By the time the majority agrees with whatever the change is, the innovation's already old news. And the people who moved first have already moved on. And this is just a natural human process. The majority's not wrong, they're just late. And because deep down, they're waiting because adoption of any new innovation is a decision under uncertainty. And most people rationally wait for social proof before they take on that risk. And the innovators and even the early adopters don't really have that need. That's that comfort with uncertainty. And then there's this part here that I haven't talked about, the chasm. Although this idea of the chasm, the gap between the early adopters and the early majorities, it's only really touched on in Everett Rogers' book. It was explored in depth in another book. This one's called Crossing the Chasm. So diffusion is the theory. This is actually the practice. This is kind of a model to spread your ideas, whatever they are. And it was all about crossing this chasm. Because this gap right here, the chasm, is where most good ideas die. Not because they're wrong, but because they haven't accumulated enough social proof. It's too out of step with the mainstream thinking, which means it's risky, and a lot of people and a lot of organizations are just risk averse. So the innovators standing on one side of the chasm and the majority standing on the other. And they're rational, and in between is that silence. So let me show you what that silence sounds like. And it starts with the majority being wrong. And this is a fascinating story. I've actually told this story two different ways. I'm going to tell you one side of this story today, and I've got another side of this story that you can check out if you want to learn a little more. But I like this because it's an everyday reminder that we can never escape about the majority being wrong. Because this little padlock icon is something we take for granted every day. And it's proof that the majority was wrong. Because for decades, the consensus in cryptography was that what this little padlock represents was mathematically impossible. Not difficult, not impractical, it was impossible. But without it, the internet as we know it today could never have existed. Because its promise is that whatever you send, whether it's your passwords or credit cards or private messages, they can only be read by the person that you're sending to them. Everybody else sees gibberish. But this was once a radical idea. This was a dangerous idea. And the thing is, the idea wasn't codes, like encryption. That's not a new idea. Humanity has been using codes for thousands of years, but there's always been a problem with codes, whether it's Caesar ciphers or one-time pads or Enigma machines or anything else. The problem is the key exchange problem. So for example, if we've got Alice wants to send a message to Bob as the lore goes, we have the eavesdropper Eve, who can actually listen in on the communications. So if you and I, for example, Benoit, we have never communicated before, maybe you're up here in Montreal and I'm down in Denver, and I want to send you something in private, the first thing that we have to do is establish a code, establish a secret, establish a key, establish something. But the only channel we have is one that's insecure, that our friend Eve can eavesdrop on. So how do we solve that problem? Now, historically, what we've always done is, we've had like military couriers and all these other very complex Rube Goldberg devices, or we would meet in secret and exchange keys or whatever else, but that doesn't scale to the internet, to the world, to anything else. And for the longest time, one of the most advanced, like going into like the 1970s, 1980s, one of the most current and advanced books on cryptography talked about this problem. By the way, this is dated 1883. This is because once we got into the 20th century, pretty much everything around cryptography got classified, got scooped up, and nobody was able to learn about it. But this Auguste Kirchhoff said the general system must be considered public information. Security resides solely in the secrecy of the key, which means the network as it still exists without this idea, without what the padlock represents, just cannot exist because we cannot keep the key secret and exchange it over the public channel. So how can we do this? Well, the majority view forever was you just can't. But enter a young grad student named Ralph Merkle. Now, he saw something that nobody else could see. He saw a pathway, he saw a possibility, he saw a way to solve this problem that looked impossible to everybody else. And he proposed to develop this idea for his computer science project. Now, his professors were like, yeah, that's a stupid idea. Project 2, that looks more reasonable. Project 1 is muddled terribly. Talk to me about these today. Basically, the professor rejected it, but he pursued it anyway. He built a proof of concept, and it worked. And he submitted his paper to one of the most prestigious technical journals on the planet. He sent it to the ACM. They took a look at it, they read it, and they basically said, this paper is not in the mainstream of present cryptography thinking. I would not recommend that it got published. And the editor or the reviewer, another reviewer who's looking at it said, I was particularly bothered by the fact that there are no references to other people having already done this. That was kind of the point. Has anyone else ever investigated this approach? No, that's why it's so exciting. And that was the problem. This is what Rogers taught us, that the most innovative member of a social system is perceived as deviant from the social system and afforded the status of low credibility by the average members of the system. And the thing is, Ralph Merkle, I hate to say this, but I'm going to say it because I can't not. Every time I look at him, I'm just like, yeah, he looks like a Ralph Merkle. I don't even know what that means. But there's a linguistic experiment where they have two shapes, and they say one are called Zorps and one are called Shizzies or something like that. And everybody agrees on how those labels get assigned to the shapes. Like almost everybody in the world agrees. They're like, oh yeah, those are the Zorps, and those aren't the right words, but you can find this experiment. I just look at him and I'm just like, he looks like a Ralph Merkle. But the thing is, he just kept going. He kept revising, he kept resubmitting, and he kept getting rejected. And he reflected on this. He says, what was striking was how the publication process was tuned to incremental improvements, but it was very bad at handling something that was just fundamentally different. And the thing is, innovation can be lonely, to be able to see something that nobody else can see, that nobody else believes. You know, sometimes you wonder, am I just a child that never let go of the myth of Father Christmas, the Tooth Fairy? I don't know. Insert your favorite childhood mythology here. But it can be lonely to see something that nobody else sees. But you're never truly alone, or very rarely at least. And so with that, on this topic, whenever we think about these great innovators in history, we like to lionize them as lone innovators, and you know, the lone genius over there that figured everything out. That's rarely how these things actually play out. It's just who got the credit. And so the thing is, you need to find your tribe. So half of the concept, like this, half of this concept, the privacy side of it, just the idea that we should be able to have a private conversation on a public network. It's a basic human right in a lot of people's opinion. And that wasn't a new idea. That had occurred independently. And because in addition to Merkle at UC Berkeley, there was other research taking place. And in fact, this whole idea of key exchange on a public network had been explored in the UK with like Clifford Cox and Malcolm Williamson at GCHQ. But all that work was classified. Nobody was ever really going to see it. And they just said, oh, this is cool, but it's impractical. The thing is, again, the majority wasn't wrong. They were just in the dark because all of that research was classified. And all of this work had to begin from first principles. And that goes back to that deep curiosity where you find a dead end and you don't say, oh, well, there's nothing else there. You say, I wonder what else is there. And just kind of pulling on that thread anyway. And the thing is, Merkle wasn't the only one thinking about this. This is John Gill and Stephen Polig, and they came up with interesting ideas to tackle this problem. Nobody knows what their name is. I would be shocked if anybody knew who these people were. But they were doing work in this space. They just didn't get a protocol or anything named after them. So resist that myth of the lone innovator. Now, we're back to the innovator's toolbox. Now, Ralph Merkle didn't quite have the necessary interpersonal network, so he didn't know about the work going on at GCHQ. He didn't know about these other grad students kind of exploring these ideas. But he was an active information seeker. And one day he tuned into a lecture that was being broadcast from across the bay at Stanford. Now, that professor who was giving that lecture was Martin Hellman. And now we're getting into names that might start to be a little bit more familiar. Martin Hellman had been thinking about the same problem. And the thing is, he was working on it in isolation until he met Whit Diffie. And see, now we're tiptoeing into the waters of the Diffie-Hellman key exchange, which was ironically created by Ralph Merkle. But I'll talk about that in a moment. But the thing is, what you have to do is you have to find your tribe. And one of the greatest things that I've discovered is that we're bad at this. I'm bad at this, at least. And I've been doing something fundamentally wrong for a lot of my life. I had this idea of who I was supposed to be, right? This goes back to this idea of diversity and homophily. And I kind of became a chameleon, that I'd be around different people and I would be that person. There was Office Mike, and then there was like Happy Hour Mike, and then there was Skydiving Mike, and then there's Scuba Mike, and there's the Figure Skater Mike, and there's the Jazz Drummer Mike, and the Metal Drummer Mike. All of these different people looked very different to the different crowds that I was around. I was trying to fit in. And all I was doing was hiding from my tribe. And so one of the easiest things you can do is just be unapologetically you. And I think this is essential in the age of AI, because AI is homogenizing everything, all speech, all communication, all writing. I used to think I was special because I not only knew what an M- was, I knew how to deploy it properly. And now everything I see posted has M- in every paragraph, and I don't feel special anymore. But what I've started doing is just like, okay, well, what's my authentic voice? That's just how I'm going to speak. And now I'm going to stand out from everything else. Now, there are people who aren't going to like me, and that's okay, because there are people who are going to see themselves in something I write or something I say. So I'm just going to be unapologetically me. That's right, the sport jacket, the pocket square, and the fish t-shirt. Like, how many things can I mix up into one outfit? But jeans, yeah, that works too. So the thing is, Diffie and Hellman, they weren't just sympathizers. They didn't say, oh, your idea is cool and we like that. They were actually collaborators. And it goes back to that idea of diverse mental models. The only way to scale your diversity of mental models is to scale out. Scale with diverse team, diverse organization, diverse interpersonal networks. And they all brought something different to the table, different perspectives, different ideas, different mental models. And so when they would get together, they didn't just brainstorm, they kept the work alive. And so Diffie and Hellman published this paper, which is an enormously important paper in the history of computer science. And it was based on Merkle's ideas. Now, the problem was it was based on Merkle's ideas, on Merkle's proof of concept, but they published it. And so today, because this is the paper and these are the authors, we call it the Diffie-Hellman key exchange. They tried to rename it Diffie-Hellman-Merkle, but that never really stuck. That's a mouthful. That's a lot of syllables. But they published this. So the basic idea of Diffie-Hellman, it uses mathematics, but I like the paint color analogy, that you have some kind of common paint color, doesn't matter what it is. If we assume that it's difficult to reverse mixing of paint colors, the same way it's difficult to factor prime numbers, large prime numbers, then we can have this common color that anybody can know. We each come up with our own secret color, either a red or a teal, and we mix our own stacks. And then we swap those, and then we mix in our own color again, and we get the common secret. That's basically the idea. It became known as the Diffie-Hellman key exchange, based on Merkle's proof of concept. Now, he didn't get the credit, but I love this quote by Harry Truman. He says, it's amazing what you can accomplish if you don't care who gets the credit. By the way, my headcanon for this quote is Harry Truman is quoting somebody else. But, he's got the bully pulpit and the power of the presidency, whatever that's worth anymore. And so he's the one who's remembered for saying it. But to be fair about Merkle, the system did fail him. But to Merkle, the work mattered more than the credit. So innovation isn't about ego. It's just about progress. It's about crossing that chasm. And that's what happened. When they published that paper reached some early adopters. And there's some really wild stories about this that are not in this deck, but I have elsewhere. They actually found an early adopter. I don't think I have it in this deck, but I'm going to tell you anyway because we've got some time. So the paper did reach some early adopters. I'm going to go back to where I was. And it ended up getting a write-up in Scientific American back in the early 1970s. And at the end, this tech journalist who was very influential back in those days, he wrote this whole thing, talked about how interesting and cool it was. And Diffie, Hellman, and Merkel said, hey, you know what? If you want a copy of the paper and the implementation, all these little details. Oh, no, actually, it wasn't them. It was these guys, the early adopters who read that paper, because they were the early adopters before it made it into the early majority. These are some folks over at MIT on the other side of the United States who read that paper and said, this is kind of interesting. We want to explore some of these ideas further. So these are the three people from MIT. This is Adi Shamir, this is Ron Rivest, and that's Leonard Adelman. They are better known by their combined initials RSA, which again, you probably heard of. And they went out, they published, they built a comprehensive and rigorous solution to the problem, mathematical solution to the problem, general solution to the problem included cryptographic signatures and all these other things. That got picked up by another early adopter who was that influential tech journalist for Scientific American. And then they said, you know what? We're so excited about this. If anybody, just put in the article, if anybody wants a copy of the paper and the proofs and everything like that, just send us a self-addressed stamped envelope. And so about a week or so later after that comes out, they walk into their respective offices and their personal assistant or TA or whoever kind of says, you got some mail, and there are bins and bins and bins and bins of self-addressed stamped envelopes. So they're like, oh, cool, the world's excited about our idea. So they're Xeroxing these papers and stuffing envelopes and putting them in an outbound bin. They're doing this again and again and again. And by about envelope 2000, they say, we're sending a lot of these. I wonder where these are going. And they start looking at where these things are going. And it's, mathematicians are interested, sure. Privacy advocates are curious about it. That makes sense. Political dissidents, freedom fighters, foreign governments. And then they start thinking, we should talk to the university's legal team. We might have committed some light treason. And in fact, they had, and it was a whole ordeal. There are decades to this story. But ultimately, it took longer than it should have, but ultimately they crossed the chasm. And the thing is, every secure transaction you've ever made today depends on an idea that was once unpublishable. Bless you. So there are things we can take away from this. One of the first ones is don't give up. I'm not even going to try to pronounce that. Resist alone innovator myth. Are these any good, by the way? I don't know. I asked AI for help. Are these okay? I was impressed. I was genuinely impressed at how well this worked. I went into Copilot in Office. I said, I'm giving this presentation in Quebec, and I want to be respectful. Can you help me translate these slides? And I thought it was going to be a lot of back and forth, back and forth. It's like, oh, no, let me think about that. And then 20 minutes later, it had actually annotated everything. I was like, and I'm spot checking some of these. I'm like, actually, that's not bad. As far as I know, what do I know? I'm always impressed by AI's output when I don't know anything about what I'm asking it to do. Less so when I know a lot about what I'm asking it to do, but that's a different issue for a different day. Find your tribe, be careful of ego. And in fact, Martin Hellman had a lot of challenges with this. I don't know why, but he made it into like a personal mission, like a vendetta almost. And because the NSA in the United States was basically trying to bury this. They were threatening everybody who was involved in this. It was a whole big ordeal. And one day he finally met with somebody from the NSA, and the first thing that he said is, he says, "Oh, I expected you to have horns." And like that was the first thing he said. That was his icebreaker. I think you're evil incarnate, but you look okay. But later he regretted that. He actually went back and said that his advice was get curious, not furious. He says friends are better than enemies. If there's one thing that he could go back and change in this entire multi-decade journey was this, just get curious, not furious. Understand that when people reject your idea, they're not rejecting you. There's a hole in their toolbox, or you might be wrong. But we'll get to that in a little bit as well, because sometimes you're just wrong. At least I'm just wrong. But ultimately, the thing is, it took years to cross the chasm, but it crossed. Somebody built it, the world caught up. And I must have screwed something up. The world caught up. Yeah, okay. I blame AI, but I'm not furious. And it kind of followed a process that was generalized by the same guy, Everett Rogers, right? The innovation development process, recognize a problem or need, given some problem through some amount of research, the innovator develops and formalizes a solution that is then packaged and otherwise kind of presented nicely so people can adopt it with a minimum of friction. At that point, the diffusion, the spreading of the idea begin, and ultimately the innovation gets accepted or rejected or adopted or reinvented or adopted and then abandoned. Like all these things happened. But again, the thing is, this is what they went through, this is what everybody goes through. But eventually, in the case of public key encryption and key exchange protocols on an unsecure network, right, the world caught up. We can take advantage of this stuff every day. But what happens when it doesn't? What happens when you show the world the future and the world just doesn't get it? Like this happened in a very real and a very tangible way. So right now, I'm giving this presentation on my personal computer using PowerPoint and some other clever things as well. PowerPoint that uses a drag and drop interface on my personal computer. I've coordinated, we did a lot of coordination back and forth, a lot of us over instant messaging. I was thinking about recording this whole thing on Zoom, but then I realized I'm on your data and I don't want to do that to you. But we've had Zoom conversations. We actually were on the same Zoom call not that long ago. All of this happening over the entire global internet. A lot of this I controlled with a mouse, my drag and drop, all of this. I used an outlining tool to kind of come up and catalog and gather and organize my ideas. I'm not sure what this one is, but it's something. I keep a lot of this stuff in a WYSIWYG maybe. I keep a lot of this stuff in a version-controlled repository. Sometimes for another event we're doing a lot of collaborative editing right now in a document in Google Docs. This was announced, published online in HTML. I got emails about it, like all of these different this is just the kind of fabric of computing as we know it today, right? All these different tools, all these different technologies, all these different things we take for granted. But at one point, these were a crazy idea. At one point, it was revolutionary. Now it's just a fabric of modern computing. Because each one of these things fundamentally changed how we work, how we build software, what kinds of problems that we can solve with software. And all of it, and a whole lot more, was invented by one person. This guy, Douglas Engelbart. And he demonstrated all of those things to the world. WYSIWYG editing, video conferencing, instant messaging, email, hypertext, version control, outlining, networking, all of this stuff over 60 years ago, or right around 60 years ago. And that all started with an idea. So this guy, Douglas Engelbart, back in the 1940s, he was in the Navy. He was an officer in the Navy, and he was a radar operator. He was already a technical kind of guy, and he had just shipped out to the Philippines. And as he was sailing west out of a port in California, he heard cannons firing and bells ringing and things like that. He's like, well, this is an awfully big send-off for our ship. Usually it's a much smaller send-off for our troops going overseas, but this was enormous. Wow. Like, I'm touched. And later, when they got into port, they found out, oh yeah, the war had just ended. So he gets dropped off in the Philippines with nothing to do. He's got no forward assignment. So he's thinking about this. What am I going to do? What should I do? He's walking around exploring the villages, and he sees a little like traditional hut on stilts. And there's a sign that says the Red Cross Library. He's like, far out, they have a library. Où est la bibliothèque? This is as good as it gets, by the way, so I'm glad you appreciate it. And so he goes in there, he finds a magazine. And in that magazine was an article. The article was called As We May Think. And it was written around the time of the first digital computers. The guy who wrote this was a guy named Vannevar Bush. Vannevar Bush oversaw all of the most advanced weapons projects and the advanced strategic projects during World War II. In other words, he was directly, like, chain of command responsible for the most devastating weapons in the history of mankind. And the war was over, and he's got this realization, like, is this the extent of my contribution to the world? And he was reflecting. And he started thinking, what could we do better? And he started realizing that during World War II, we had enormous resources, money, time, personnel, expertise into building weapons of war. And now the war's over and the government's like, hey, great, we won. And so it's back to business as usual. And he said, what if we didn't go back to business as usual? What if we kept that level of investment, we kept that energy, we kept that dedication, but instead of kept the target of building weapons of destruction, what if we used technology? We built technologies that could augment humanity, augment the human mind. And at the time, the whole essay was a little too out there. It was hypothetical, what if, blue sky thinking of the worst kind, and it didn't land for most people. But it landed for that guy, Douglas Engelbart, while he was stationed in the Philippines. And he said, when I get out, I'm going to make that vision a reality. See, there was a time when the dictionary definition of a computer, in fact, this was the time where if you looked up a computer in a dictionary, the definition would be one who computes. Computing was an occupation. It was semi-skilled labor at best. At the time that Vannevar Bush wrote that essay, he likely knew of exactly one computer in existence, computer as we know it, sort of. This is not a computer. This is a digital electronic programmable-ish computer, but not in the way that we know it. There's no screen. There are no buttons. It doesn't take punch cards. You actually literally program it by plugging together circuits and logic gates. So this was the first digital electronic programmable computer, and it just automated the work of human computers. But essentially, it was just a hot, loud, expensive, programmable calculator. That's all it could do. At least that's what most people saw. But when Douglas Engelbart saw these machines, he looked at early computers and he saw all of this and a lot more. He saw the complete picture. And he would describe these ideas to anybody who would listen. And those ideas just didn't land. Like, people just didn't get it. They're like, what are you talking about? That's not how computers work. Or he would talk about networking, and they'd say, why would you want to connect two computers together? Right? It doesn't make any sense, because they were thinking as far as what he said, not as far as what possibilities that opened up. And you can't see the whole picture when I just give you two puzzle pieces. What is this? You might be able to intuit. You're a smart guy. You might be able to do it. But generally, it's hard to put those things together. But he had this vision, and it was unshakable. And the more he talked to other people, the more he realized that nobody else was going to see it. If nobody else could see it, then nobody else could do it. That meant it had to be him. And he dedicated his life. He left the Navy, and he went back to school and spent 7 years getting his PhD, because he realized that what he was imagining was a little above his pay grade. He had to learn the skills to build his dream. And then he worked mundane jobs. One of the biggest mundane jobs that he had was as a researcher for the Stanford Research Institute. And he just did really conventional research. In other words, from the idea to actually building it, it took about 15 years for the real work to begin. But the thing is, He had more than a dream. He had patience and he had discipline. So just like Merkel, he kept trying to get attention. He kept applying for grants. He kept getting rejected. And then somebody somewhere said yes. One person is like, I find your ideas intriguing and I would like to subscribe to your newsletter. And my references don't get any less obscure than that. But he got a grant from ARPA, the Advanced Research Projects Agency, and they ultimately profited handsomely from his work. But it was a small grant, and he wrote a paper. He laid out the theoretical framework for the entire vision. And this got attention. He got bigger grants, multiple grants. He wasn't just thinking about these ideas anymore. He had the resources, the money to hire, to build his own lab and make this vision a reality. And basically, none of the foundation for any of this vision existed. So he had to build everything in a vacuum. But he got a team. He began what ultimately became known as the Augmentation Research Center, and that was inside the Stanford Research Institute. And but at the same time, as they're doing this, as they're building this, as they're seeing the dots connect, they're moving forward, they're making progress. They're coming up with concepts like this that nobody else would ever have imagined. Almost everybody in the computer science community thought this guy was a crackpot. Even his boss at SRI thought he was a crackpot. At one point, Englebart's boss just jumped on a plane from California, flew all the way over to the East Coast to meet this guy, Bob Taylor, who was a program manager at NASA because NASA was one of the people who were funding his research. And he flew all the way over there for the sole reason of saying one thing. He goes and barges into this guy's office and he says, I want to talk to you about Doug. Why are you funding this guy? Yes. And the thing is, what he was doing, it wasn't just wild ideas. Shortly after this whole exchange took place, Bob said, I don't know what to tell you. I like what he's talking about. But shortly after that exchange, Douglas Engelbart gave the most important technology demo in history. To this day, we refer to it as the mother of all demos. Not the iPhone, not the Macintosh, this one. Because in this demo, in 1968, he showed us everything. The mouse, the graphical user interface, drag and drop, video conferencing, real-time collaborative editing with somebody who was on the other side of the state. All these different technologies that I listed in the beginning were in this demo, and that's why we call it the mother of all demos. His team built it, all of it, and it worked. And the response was a mix of, well, awe and bewilderment. Like people were like, that's cool, but people weren't really sure what to do with it. Now, 3 or 4 years later, Engelbart repeated this hypertext meets desktop sharing, meets video conferencing, meets the mouse, the graphical user interface, everything demo. And in the audience was what was said to be one of the best and brightest computer science processors or computer science professors of the era, according to a guy, Andreas Van Dam. And he said he was among that in the room was the best and the brightest of the 1970s computing cognoscenti, right? The IT intelligentsia. And he gives this demo, this history-changing demo. And the brightest and most respected professor in the room raises his hand and says, I don't get it. The demo landed with a thud. And the thing is, this professor said, that's cool, but everything you've shown me, I can do with my ASR 33. Now, for the non-old white geeks in the room, this is an ASR 33. It's a standard issue teletype. Basically, all it does is does nothing but print out what you type into it, but it's connected to a computer, and when and it's also plugged into standard out and print standard out. So standard in, standard out, all print on this paper. That's it. And that's all this thing could do. And so he's showing the mouse, the graphical user interface, video conferencing, hypertext, all of this stuff. And the guy's like, I can do all that with this. And I guess like in a Turing sense, sure. But that was completely not the point. Like from a capability standpoint, it was night and day. And Van Dam said, if the best and the brightest can't understand what he's doing? What hope have we got? And the thing is, the demo didn't cross the chasm. It was too innovative. Like nothing happened for a long time. And in fact, things went downhill. No, it's not nothing happened. Things happened. They were just all bad things, right? The team fractured because Doug's vision was computing as this like thing for all humanity. And the team was like, it'd be really cool, personal computers where we all had one and we could still connect them and solve problems for humanity, or, cat pictures. But they fractured. They wanted to go in different directions. And pretty soon they all packed up their ideas and they packed up Doug's ideas and they walked 4 miles down the road to another lab that was founded by Xerox. Then Doug lost his funding. Then he got fired. And then his research got sold off. And then his house burned down. It was a bad couple of years for Doug. But the thing is, he never let that defeat him. He spent the rest of his life pushing for these ideas. And the reality is, like he kept working, even when he retired in the 1980s, he kept working into the 2000s. And the craziest thing about this story is we did eventually get his tools, but we never saw his vision. I'm doing this in the wrong order. Sorry, let me rephrase that. And he kept working, nobody ever understood, and nobody else ever saw his vision. That's how I'm supposed to set it up, now that I remember. Never saw his vision, because then you can say, but Michael, we have all of these things. You made it sound like his ideas never crossed the chasm. Well, they didn't. That's the most heartbreaking part of this story, is they didn't. Because around the same time that the iPhone was released, so in the early 2000s, mid-2000s-ish, he was interviewed and he got asked a simple question. How much of your vision? Because by this point, the Xerox Alto had been around, the Lisa had been around, the Macintosh had been around, Windows had been around, the internet came, the World Wide Web came, all of these things. All of these things have materialized that I talked about. And now we have a supercomputer in our pocket, and a global wireless network, and everything else. And so this interviewer said, you must be proud seeing how much of your vision we've actually achieved. And he said, we haven't. He said, what do you mean? He says, we're not even close. And the interviewer said, okay, how much of your vision have we actually built in the technology industry since you had this idea back in the 40s and 50s? And his answer was very precise, 2.5%. Everything that we take for granted today started in his lab, including the internet, including the World Wide Web. Yes, the internet started in his lab. The first 2 nodes of ARPANET that would eventually grow to be in the internet was one of those nodes was in his lab. The first message ever sent over the internet arrived at Doug's door. His ideas around hypertext led to the World Wide Web in a roundabout way through Tim Berners-Lee. All the things we got with the Lisa, the Macintosh, and everything else, 2.5% of the vision that he first started to see in the Philippines. Right? This wasn't his vision. This is just the scraps that we scavenged. And we have to wonder about this. Well, what went wrong? One of the things that he tried to do is he tried to do everything at once. And so, like, my advice, and I've done this, and it's never ended well. So one of the most important things is don't try to boil the ocean. It takes a lot of energy, and it's very, very, very hard to do. Like, Engelbart's vision didn't fail because it was wrong. It failed to cross because he tried to deliver the entire thing at once, and the world just couldn't receive it whole. It received it in fragments, carried by other people, usually without credit. Like, right before he retired, he watched Steve Jobs walk on stage to a standing ovation, demoing all of his ideas and getting all of his credit. And also realizing that they missed the bigger thing, and how excited everybody was for the tools that opened the doors to the adjacent possible, but they missed the bigger thing. One of my favorite movies is The Prestige. And I love this scene where we meet Nikola Tesla, ably played by David Bowie. And he talks about this very same problem.
I need something impossible. You are familiar with the phrase, man's reach exceeds his grasp. It's a lie. Man's grasp exceeds his nerve. Society only tolerates one change at a time. The first time I tried to change the world, I was hailed as a visionary. Second time, I was asked politely to retire.
I like this because in a lot of ways, Douglas Engelbart is to computer science as Tesla was to electrical engineering. We don't know all of Tesla's ideas. We probably won't learn them in our lifetimes. And they both had the same problem. They both saw too far. Like Doug had a vision that reached centuries into the future. Like that can be a blessing, but it's also a curse, especially when almost the rest of the world thinks solely in quarters. And that's why he wasn't just an innovator, he was way out here as a visionary. But even the innovators can't see that far. Doug could see beyond this idea of the adjacent possible. So the vision didn't cross the chasm, but pieces did, right? The team took the interface to Xerox and put it in the Xerox Alto. Steve Jobs took the interface to market. The internet started in his lab. The first message ever sent over, like I said, arrived at Doug's door. Tim Berners-Lee took the idea of hypertext and to the internet and to the World Wide Web. And his vision, though, wasn't to have better tools. His vision was to augment the human intellect. And when we look from a narrow perspective, it feels like we've come a long way. Now, I have issues with the guy, but I can't argue with this. This interview right here.
I remember reading an article when I was about 12 years old, I think it might have been in Scientific American, where they measured the efficiency of locomotion for all these species on planet Earth. How many kilocalories did they expend to get from point A to point B? And the condor one came in at the top of the list, surpassed everything else, and humans came in about a third of the way down the list, which was not such a great showing for the crown of creation. And but somebody there had the imagination to test the efficiency of a human riding a bicycle. Human riding a bicycle blew away the condor, all the way off the top of the list. And it made a really big impression on me that we humans are tool builders, and that we can fashion tools that amplify these inherent abilities that we have to spectacular magnitudes. And so for me, a computer has always been a bicycle of the mind, something that takes us far beyond our inherent abilities. And I think we're just at the early stages of this tool, very early stages. And we've come only a very short distance. And it's still in its formation, but already we've seen enormous changes. I think that's nothing compared to what's coming in the next 100 years.
And he's right on that scale, the next 100 years. There are a lot of people who speculate it's going to take us at least another 150 years to understand what Doug was building. But even Jobs sensed that there was more. And so for all of this progress, this is as far as we've made it. And I think that's an important thing to realize, is that some ideas don't win arguments. They just keep getting built on. And sometimes the most important work you can do as an innovator is just to make sure that the work doesn't stop. So sometimes you're the one who takes the idea across the chasm, and sometimes your job is just to make sure that the work doesn't stop. I'm getting ahead of myself here. Now, you might be thinking at this point that, okay, innovation requires you to be extraordinary, because we have met some extraordinary people so far. But anybody can be an innovator. Anybody can change the game forever. And sometimes your very weaknesses are your hidden strengths. And that's an easy thing to accept at a tech talk about innovation, but it's a hard thing to accept about yourself. And that's okay. You don't have to accept it right now, but it's true. And I will prove it. This is Dick Fosbury. Around 1962, Dick Fosbury was in American high school, and he wanted to play sports. His family, is a sports family, and they like sports, and you're going to grow up and be a sports ball player, right, son? Chip off the old block. You're going to live out the successes that I never did. You're going to be my do-over, son. Is that You got American football every year for Christmas, or a basketball, something like that. And so he wanted to play in sports, but you don't look at this guy and be like, yeah, that's an athlete right there. He's a scrawny, short, white guy. So as an athlete, he was unremarkable, right? He wasn't big or strong enough to play American football. He didn't have the endurance to do a lot of other things. And so finally, I don't know how it works up here, but in the US, there's like one athletic activity, extracurricular, that they'll just accept anybody. It's the theater of sports. It's the island of misfit toys, and that is athletics or track and field. And so he got pulled in there like, I don't know, we got like 30 different events. We'll find something that you can do passably. And he ends up doing the high jump, and he's terrible at it. Now, the state of the art for the high jump was this right here. It was the scissor technique. And it helps to be able to do this if you have very long legs that are very, very, very limber. He had neither of those two things. So at this point, he couldn't even clear a 1.5 meter bar doing a high jump, the way that everybody did, the way that wasn't just the majority. This is literally how everybody did it. He couldn't clear 1.5 meters. And he wasn't good enough to use that technique. And that's the superpower. Because when you can't do the obvious thing, it forces you to do the creative thing, the thing that nobody else sees because nobody else ever looked for it. He developed his own technique. He just got out there when nobody was around and played and explored and tried out a bunch of different ideas. And he wasn't trying to fix it. He was just playing. He was like, what if I do it like this? What if I do it like that? And then something clicked, and he cleared the bar, and he moved it higher, and he cleared it again, and he moved it higher, and he knocked it over, but he figured out what he did wrong, and he put it back up, he cleared it again. And he worked on this, and then they went to the track meet. And while everybody is jumping over the bar like this, he shows up jumping over the bar like this. Everybody laughed at him. This is now known as the Fosbury flop. And I don't think it was a term of endearment at the time. Oh, there he goes with the old Fosbury flop. The first time the world saw it, like I said, they laughed. He was an innovator. He was a deviant. And then he started winning. By the end of the year, he shattered the highest anybody had ever jumped at that school. And he was so good, he got a full scholarship to the University of Oregon. And then he shattered the university record. In 1968, he represented the United States in the Olympics. Not only did he win a gold medal, but he destroyed the Olympic record, jumping 2.25 meters. And in that moment, on the international stage of the Olympics, the game was forever changed. If a competitor wasn't using the Fosbury flop, they were not competitive. They were obsolete. They were redundant. And since then, every high jumper, all the high jumpers in the world, use his technique. It wasn't brilliance. It was the constraint that was the key. Like I said, sometimes your weakness is your superpower, because when you can't do the obvious thing, you're forced to try the creative thing. Now, there is one aspect, though, of all of this stuff that I haven't talked about, because every story that I've told is about a person with an idea that the majority thought was wrong, and the innovator kept going. But there's this little thing that nibbles at the back of my mind called the Dunning-Kruger effect. And you know what? We've just hyperscaled Dunning-Kruger effect. Because I have my idea, and I talk to maybe a person, and maybe I get the right person, maybe I get the wrong person. But usually somebody says, that's crazy. Or I don't even know who I can talk about. You know who I can talk to? Claude. You know what Claude's gonna say? What a great idea. You're absolutely right. Now you're thinking like an engineer. And it goes back to this whole thing about AI, that when I don't know much about what I'm asking AI to do, I think the results are amazing. Like my machine translations. And I hope they're okay. I mean, he's getting that's a good problem for AI. Like that's the sweet spot for what a language model can do. But the reality about the peak of Mount Stupid and the plateau of sustainability is both of these things feel the same. And if you're self-aware enough and you have an idea, or you've been sufficiently beaten down by society and corporate culture and all the rest of it, you're always going to wonder, am I here or am I there? How do you know when you're Fosbury or chasing folly, right? There's a great article, great essay, which is definitely worth a read, on dadetech.com called How Developers Stop Learning, The Rise of the Expert Beginner. It's a great blog post. And he talks about this thing that happens to a lot of engineers, that we make fast progress and then we just suddenly stop learning. It's a great blog post. All right, you got it. And the analogy that he uses, he shares a story about him learning to bowl. You know, everybody told him there's a right way to do it. You gotta line up, you gotta do one of these, you gotta have the 1 foot in front of the other, the 5-step, and follow through and all of that. And you're aiming for the pin, you gotta get a little twist. I don't know, I'm not a good bowler. I tried. All I did was screw up my wrist. But he shares his journey about learning to bowl. And he says, most people bowl by putting a thumb and 2 fingers into the ball and carefully cultivate tossing that bowling ball in the pattern that causes the ball to start wide and then hook into the middle and hit the pocket of the pins. He said, I had no patience for learning that. And I discovered that I could do a pretty good job by faking it, putting no fingers in the ball and just kind of twisting my elbow and chucking the ball down the lane. And he made real progress, right? Rapid progress. He said, I rocketed up to 130, 140, all the way up to 160 range within a few months of bowling in a league. And then a strange thing happened. I stopped improving. Right at around 160, I topped out. And that was his metaphor for the expert beginner, because we do this as engineers, right? The expert beginner short circuits the skill acquisition model. And so sometimes you think you came up with something brilliant, and it turns out you just learned it wrong. So how do you know if you came up with a revolutionary new bowling technique, or a not revolutionary bad bowling technique, or you invented the Fosbury flop? Well, I call it the Fosbury of Folly framework, and we'll close with this. The first one, the questions to ask yourself in those moments of doubt where you're not sure, and ask yourself, not Claude or any of the other ones, are you challenging assumptions or avoiding mastery, right? This is the expert beginner diagnostic. See, he skipped the fundamentals bowling, but Fosbury tried the conventional way, and it genuinely didn't work with his body. Engelbert spent 7 years getting his PhD. So the question really isn't whether you reject the orthodoxy, it's more, have you wrestled with it first? The second one is, does your idea solve a real constraint, or does it just express a preference? Right? This is Fosbury's physics. The flop solved a center of mass problem that scissors technique couldn't. So the real breakthroughs will change the whole trade-off surface. So remember that the contrarian rejects without understanding why they're rejecting, but the innovator rejects after understanding and because they found a constraint that the orthodox approach accepts as invisible. The third is, does your idea get stronger under skeptical attack? This is actually where AI is useful, by the way, because I will usually ask AI to play a very effective devil's advocate, and I give it kind of a persona. I'm like, okay, I have some ideas around AI and semantics and all this other stuff that I finally figured out how to explain. And I will say, okay, here are 6 different personalities, right? There's the standards nerd, there's the hardcore contrarian, there's the expert in the orthodoxy, and other people who've tried this approach and failed for whatever reason. And I'm like, how would each one of these people attack my argument? That's fun. And it's also a lot safer than going out and going places and having people attack you directly. But that does happen. That happened to me in India. I gave a talk, and a guy came up to me afterwards. He says, you're absolutely wrong about everything. And I think I posted something on LinkedIn not that long ago, and a guy shows up, and he just said, I I think I was talking about AI hallucinations and grounded epistemologies. He's like, I think you're the one hallucinating here. And like, that was it. And that's it. You can't have good dialogue in the comment section ever. And I run a YouTube channel now, and so like I'm impervious to comments at this point. My wife and I, we have this very bitter liqueur that we got from Hungary called Unicum. And so we still have some because it lasts a long time. It's not something that you quaff by the bucketful. It's how did he describe it? Do you remember?
No, there's like coffee and medicine and alcohol and something else.
I think he says this because it's like the national spirit of Hungary. And one of the locals said that it's like, I think he said it's like Jägermeister that's been cursed by 5 witches. So it's very bitter, gnarly stuff. And my wife and I, when we get the meanest comments, like some of the ones that get auto-moderated, we can still see them. The meanest comments, we will pour a shot of this stuff and we drink the haters' tears. We toast the haters' tears. But you know, it's like, I will say that the LLM is a safer space to kind of engage in this dialogue if you haven't been hardened by the reality of spending any amount of time in the YouTube comments on something that you poured your heart and soul into. But it's a useful thing to do. And the thing is, Merkel's ideas, despite the fact that they were rejected for publishing, the idea survived the institutional rejected, the peer dismissal, the government suppression. And in fact, every attack sharpened it. So the question you want to ask when somebody smart disagrees is, are they revealing a fatal flaw, or are they assuming a constraint that doesn't actually exist? So I try to create steelman arguments for these things. You know, be like Doug, approach with rigor. Be like Ralph and, you know, try to iterate on communicating ideas. The last one is, do the results improve as you push further? And I think this is the most empirical signal, but just remember, this is a lagging indicator, right? The beginner pattern we saw with the bowling, it was the improvement, then the plateau. The breakthrough pattern was the awkward early results, the gradual improvement, the sudden leaps. And see, the thing is, when Fosbury started this, his jumps were initially worse. But then he started winning, and then he started shattering records. And so that trajectory is the real signal. So this is the entire framework, double bulleted because that seems like a good idea. But useful to think about as somebody who saw yourself on that list. It means that you are in the 2.5%, that you will probably see something go down this road at some point. And we're in brand new, wide open territory with AI and everything else. There are a lot of opportunities for innovation. There are a lot of old ideas that are waiting to be rediscovered. And so if you saw yourself on that list earlier, keep this checklist as the check. This is the framework. This is the diagnostic. But I will say one more thing. I want to leave you with something else, because if you're sitting in this room right now and you're seeing something that nobody else can see, just remember, being ignored isn't proof that you're wrong. A lot of times it's proof that you're early. And the reality, as expressed by Mahatma Gandhi, he said, first they ignore you, then they laugh at you, then they fight you, and then you win. Assuming you cross the chasm, and that's the part that you don't control. And that's the part you should not internalize. If it's important, do it. Richard Hamming, the error code guy, among a lot of other things, he's a smart guy. I love distilling somebody's entire life's work into like one pithy sentence or one pithy label, the error code guy. But, you know, basically our entire world operates on top of his ideas with error correction and all of these things. He said that if you don't work on important things, it's unlikely you'll ever do important work. And the important stuff isn't easy. And sometimes you are the only one who has that right constellation. But it means you're going to be the deviant. Rogers called this deviance. Apple, again, complicated feelings about Steve Jobs, but Apple called this something else.
Here's to the crazy ones, the misfits, the rebels, the troublemakers, the round pegs in the square holes, the ones who see things differently. They're not fond of rules, and they have no respect for the status quo. You can quote them, disagree with them, glorify or vilify them. About the only thing you can't do is ignore them, because they change things. They push the human race forward. While some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.
Still a great ad. But the thing is, most innovators don't quit because they're wrong. They quit because the middle part takes too long. So if you saw yourself anywhere in this talk, because there's a lot of cool ideas and the world needs better ones, believe me, hang in there. I'm rooting for you.
Wait, there's not the cat? Cat will be on?
I should put that in there. All right, I will. I'm going to work that into the next version of this talk. But like the classic original, like 1976 one. Yeah. But hang in there. I'm rooting for you. We're all rooting for you. And yeah, thank you. I'm going to stop the recording there.